Now the next part of electronic measurement system, and that is digital storage oscilloscope. There is a problem with CRO. CRO is not a storage kind of instrument. What is that storage kind of instrument? In case of CRO, what happens? You apply the signal that you want to measure, okay, and the CRO will show you the shape of waveform on the screen. You can set times per division, you can set volts per division on the screen and take measurement. As and when you remove the input signal, the screen will not show you the signal because signal has been removed, okay. Secondly, the measurements that you are interested in have to be done by an individual, okay. You have to involve yourself in taking measurements, fine. So there is possibility that by mistake you make some wrong measurements, that therefore the experiment can go wrong. That is why we have got a storage kind of oscilloscope which can hold the signal as long as you want, and it will use digital electronic circuits that will perform the measurements actually. Person will not be involved in taking actual measurements. Measurements will be done by digital circuitry and it will be displayed on the screen. The block diagram of digital storage oscilloscope is this. Now you can see that there are few sections shown in this colored block. Data acquisition and then data display, and remaining is your control circuitry, okay. So basically what is case with digital storage oscilloscope is it can convert your signal into digital form so that it can perform measurement and it can store the signal in memory, okay. So basically it requires a digital circuit that can store the waveform and which can perform the measurement, okay. So let us see the blocks one by one. Input is given to the data acquisition block. Data acquisition block is the block which is responsible for acquiring the signal, okay. It acquires signal from external world, or we simply say the input the signal is given to the data acquisition system. What is there in data acquisition system is a collection of three blocks: buffer amplifier, sample and hold, okay. S and H stands for sample and hold, okay. So the second block is sample and hold. Third block is ADC, that stands for analog to digital converter. So buffer amplifier takes the signal from external world, it cleans up the signal, it keeps intact from the further blocks and keeps the system away from loading. Means the buffer amplifier handles loading effect. It does not allow signals or any other things to create loading effect on the further blocks, okay. So buffer amplifier is a unity gain amplifier. It takes the signal and gives it to the sample and hold circuit. In sample and hold circuit, it simply takes the samples of the signal. Samples means points of the signal. If there is a sine wave, it will take 100 samples of sine wave, or it may take more than 100 samples as per the setting and specification of the instrument, okay. The more the samples, the better will be the measurement. So sample and hold circuit will take the samples and give it to the ADC. Now ADC will convert each of these samples into digital form, that is in the form of binary number. So all those binary numbers, bits, are given to the further section which is memory. Now here at the input side we applied signal which is in the analog form, and at the output of ADC we have got digital form. Now the digital form can be stored in the memory, So ADC is connected to the memory. Now here we store the signal. Now the stored signal can be retrieved as you wish. Okay, so it has got specific memory given in gigabytes. So if memory is over, you have to remove some of the files from the memory, then only it will accept further signals. Okay, so the memory then is connected to the DAC. Now what is the further block is display unit or data display unit, which consists of few blocks. What is the purpose of data display unit? Data display unit will take signal from memory and create the waveform and show it on the screen. Fine, it will take the signal from memory and it will create the waveform and show it on the screen. The waveform is shown on screen. The screen that we are using in this block diagram is CRT, but in some of the DSOs they don't use CRT, but they use TFT displays, electronic displays. Okay, LCD. But in some of the DSOs we have CRT. That is why in this case we have got two amplifiers, vertical amplifier and horizontal amplifier. This is vertical amplifier and this is horizontal amplifier. As we know that in CRT we have got two types of deflection plates, that is vertical deflection plate and horizontal deflection plate. In order to drive those plates, in order to move the electron beam in a proper direction, we have got these two amplifiers. Fine. Now what is happening is the data is stored in the memory in the form of bits, which is digital form. Now this form is used for creating the waveform, but CRT is not able to handle the digital data. That is why you have to convert this digital data into analog form. That is why we have got this DAC. DAC stands for digital to analog converter. Digital to analog converter takes data in digital form and gives you data in analog form. Okay, so the output of DAC is same signal but in the different form. So analog output is produced by DAC and it is given to the vertical amplifier, and vertical amplifier drives the vertical deflection plates. Similarly, here we have time-based generator, a time-based counter which produces timing information. This timing information is analog in nature. That is why you have to convert it into, this is in digital form. That is why you have to convert it into analog form with the help of DAC. So we have got one more DAC in the lower side in the horizontal section. Okay, so this DAC converts the timing information in analog form. Okay, that sweep is generated with the help of this time-based generator, and DAC converts that digital sweep into analog sweep. Okay, and then this sweep is then connected to the horizontal amplifier, which drives the horizontal plates in order to move the electron beam horizontally. And this, both of the amplifiers, vertical amplifier and horizontal amplifier, both of them are connected to CRT, and this CRT produces waveform on the screen. Apart from this, we have got some control circuitry which controls all of the blocks in order to prepare waveform accurately. The control circuitry controls sample and hold circuit, it controls ADC, it controls buffer amplifier, it controls time-based generator or time-based counter, it also controls the memory. Okay, so control circuit is almost connected to most of the sections. Okay, if you simply show it connected to data acquisition system, simply showing it connected to the storage system and the data display unit, that will be sufficient. Okay, so we don't have to write how these control circuits interact with sample and hold circuit, how it does it interact with ADC. No, that's not required. What all you have to say is control circuit controls the data acquisition system, it also controls the display section, and it also controls the memory. Fine. And then there is something called as trigger. So triggers are of two types: internal trigger and external trigger. When you produce the trigger internally in the system, we call it internal trigger. When you receive this trigger externally from external world, we call it external trigger. So this is how we get the digital signal on the screen, and we get a copy of it in memory. If you need it, if you need the waveform even when your original signal has been removed from the system, you can get that signal with the help of this memory. So that is why on this digital storage oscilloscopes we have USB port in order to access the memory. Okay, and the actual measurement, that is voltage, current, time, frequency, phase, spectrum, etc., are done electronically. No person is involved in taking these measurements. So this DSO is better than CRO. Okay, but DSO is delicate than CRO. DSO is costly than CRO. DSO is highly accurate, and it offers many options in measurement than your CRO.